let's look at number 3. The indefinite integral of the natural log of x dx. Not basic form, not a u-sub, so let's use integration by parts. We need lie to help us determine what u should be. Well, it says if log is present, well, I have a log, so I know that my u is going to be that natural log of x. If u is equal to the natural log of x, let's go ahead and just find that derivative. Our du would equal 1 over x dx. Our dv is everything that's left over. Well, the only thing left over is dx. So when I integrate dx, I end up with x. I know that this is going to equal u times v minus the integral of v du. Cleaning this up, we have x times the natural log of x minus, well, x times 1 over x, those are just going to cancel, and that's just now the integral of dx. Well, I can integrate dx, that's basic form, so this becomes x natural log of x minus x plus c. Number 4, the indefinite integral of 4 arc cosine of x dx. Well, this is not basic form, and it's not a u-sub, so I use liate. I know I need integration by parts. I don't have a log, but I do have inverse trig, so I'm going to let my u equal the inverse trig. In this case, my u is that 4, and instead of writing arc cosine, I'm going to go ahead and just write inverse cosine of x because it's less strokes of the pen. Now we need to find the derivative. Well, recall that the derivative of the inverse cosine of x, or let's just say the inverse cosine of u, so we'll do it more in general, is equal to negative u prime over the square root of 1 minus u squared. So in this case, my u is going to be x. But don't forget about this 4, this constant multiplier that's going to multiply along. So we say that our du here is equal to, well, it's going to be negative u prime. So in this case, it's going to be negative 4 because the derivative of x is 1, but times 4 is 4. So negative 4 over the square root of 1 minus x squared dx. Now the rest of it is my dv. Well, the rest of it is dx. And if I integrate dx, I get x. So I know that this is equal to u times v. So 4 inverse cosine of x times x minus the integral of x times negative 4 over the square root of 1 minus x squared dx. Cleaning this up, we have 4x times the inverse cosine of x, and then minus a negative is a plus. I can pull that constant multiplier out of the integral, so then that's 4 times the integral of x over the square root of 1 minus x squared dx. Well, x over the square root of 1 minus x squared dx is not basic form, but it is a u-sub, so we're going to do a u substitution on this, but I'm going to use the letter w because we've already used the letter u to represent something else in this problem. First, rewrite it with a rational exponent and get it out of the denominator. This becomes x times 1 minus x squared to the negative 1/2 dx. Then, if w is equal to what's being raised to a power, my 1 minus x squared, the derivative dw would equal negative 2x dx. Well, I don't have a negative 2x dx. All I have is an x dx, so I divide by 2, and negative 1/2 dw is equal to x dx. Now let's keep going. Bring this down. This is going to equal 4x inverse cosine of x plus 4, and then this becomes the indefinite integral of w raised to the negative 1/2, and my x dx is my negative 1/2 dw. Cleaning this up, this is a minus 2, and if I integrate w to the negative 1/2 dw, it's going to be w raise it to 1 more, which is a half, times its reciprocal, which is 2, plus c. In the end, get out of your w's and go back into x's, and we end up with 4x times the inverse cosine of x, and then minus 4, and 1 minus x squared to the 1/2 plus c. And if you wanted to, you could have put the radical back, but we are just going to leave it to the 1/2 power. Number 5 is the indefinite integral of x over the square root of 6x plus 1. Well, there are two ways to do number 5. One way you already learned, it's a change of variable or a double linear problem that you would have seen in Calculus 1. And the other way to do this is using integration by parts. I'm going to show you integration by parts first on the left-hand side, and then we're going to do it the way that we did in Calculus 1, and then we'll have to factor to get to the same answer on both sides, but we'll just do that to show you that you do get the same answer no matter which way you do it. First, let's do this by integration by parts. If I'm doing this by integration by parts, or even if I'm doing this as a change of variable, I'm still going to want to rewrite this guy. So if I rewrite this, this is going to be x times 6x plus 1 to the negative 1/2 dx. Now, doing this by integration by parts. We use Lie8 to help us choose u. Well, Lie8 says logs, nope. Inverse trig, nope. Algebra, yes. But we have two algebras. This is algebra, and so is this. So which one of those do I choose? Well, you want u to be the thing whose derivative is easier, but you also need what you choose for dv to be something that you can integrate. U needs to have the easiest derivative, but you have to have a dv you can integrate. So the question is, whose derivative is easier, x or 6x plus 1 to the negative 1/2? X is easier. Well, can you integrate 6x plus 1 to the negative 1/2? Yes, you can. Because you can integrate the other part, and the easier derivative goes with x, your u is going to equal x. So if u is equal to x, over here with our table, our du is going to equal dx. Recall our dv is going to be everything else. Our dv in this case is our 6x plus 1 to the negative 1/2 dx. Well, usually we'd use a u substitution or a substitution to work that out, but notice that this guy here is linear. So let's try to do it without a substitution. How would we do that without a substitution? Well, we would think if we were doing a substitution, this ends up being a w to the negative 1/2 dw, which if we integrate is just a 2w to the 1/2. So in this case, it's still going to be a 2. It's still going to be a w. Our w is 6x plus 1. It's still going to be raised to the 1/2 power. But the only thing that we have to do additionally is multiply it by the reciprocal of the coefficient of the x term. So what's the reciprocal of 6? 1/6. If we were to clean that up, I'm going to move v right over here. V is going to equal 1/3 times 6x plus 1 to the 1/2. If you still need to use a substitution to find that integral, go ahead, but the sooner that you can integrate your linears without having to perform the u substitution, the easier that integration becomes in this section. All right, now we know that the indefinite integral of x times 6x plus 1 to the negative 1/2 dx is going to equal u times v, 1/3 6x plus 1 to the 1/2, minus the integral of v, still that 1/3 6x plus 1 to the 1/2, and then du, which is dx. Let's clean this up before we integrate again. So we have x over 3 times 6x plus 1 to the 1/2, and then this 1/3 can be pulled out of the integral, so negative 1/3 the integral of 6x plus 1 to the 1/2 dx. Well, can we integrate this? Yeah, if we need to use a u sub, we can. But remember, it's basically just a w to the 1/2 power. So if we were thinking of it that way, we know it would be times the reciprocal of that, 1/6, w, which is 6x plus 1, raised to the 3/2 times the reciprocal of 3/2, which is 2/3. still plus c. Cleaning this up, we end up with x over 3 times 6x plus 1 to the 1/2, and this becomes 1 over 27 times 6x plus 1 to the 3/2 plus c. Now if you were doing this in the homework, you would stop right here. But because we're going to do it two separate ways and I want to show you that they're equivalent to each other, I'm going to take a couple extra steps here and factor so that we see that we get the same answer no matter which way we do it. If we were to continue and factor out the GCF would be 1 over 27 times 6x plus 1 to the 1/2. If we factor that out of this first term, we'd be left with 9x. If we factor it out of the second term, we'd be left with a 6x plus 1. Distributing the negative there and combining like terms, that would be 1 over 27 times 6x plus 1 to the 1/2, and then 9x minus 6x becomes 3x, and then minus 1 when we distribute the negative. Again, on a homework or on an exam, you could leave it at that highlighted portion. We just did more because we're going to do it a different way, and I want to show you get the same answer no matter which way you look at it. So I said that you could have gotten this problem in Calculus 1 and that it would have been a change of variable problem. Well, what I mean by that here is that, well, if we would have let u equal 6x plus 1, the thing that's being raised to a power, our derivative, du, would have been 6 dx. Now, I don't have a 6 dx, I have an x dx, but if I were to divide both sides by 6, and then come back to this guy here and solve it for x, so solving for x, we would have had u minus 1 equals 6x, and then u minus 1 over 6 equal x. I could then take everything in this integrand and rewrite it with u's. I could make my x into u minus 1 over 6. I could make my 6x plus 1 to the negative 1/2 a u to the negative 1/2. And I could make my dx a 1/6 du. Now, this 6 in the denominator is a constant multiplier. I can take it out of this integral, and now we're looking at 1 over 36 times the integral of u minus 1 times u to the negative 1/2 du. I could then distribute my u to the negative 1/2 and end up with a u to the positive 1/2 minus u to the negative 1/2 du. Then I would integrate this, and I would get 2/3 u to the 3/2 minus 2 u to the 1/2 plus c. Distributing the 1 over 36 and putting the 6x plus 1 back in, we would have 1 over 54 and then 6x plus 1 to the 3/2 minus 1 over 18 times 6x plus 1 to the 1/2 plus c. Now, if you were doing it in this format, you would stop at this point right here. You wouldn't keep going, but what I'm going to do is I'm going to go ahead and factor that just to show you that you end up with the same answer you did using integration by parts. If I take out the GCF, the greatest common factor, well, that would be 1 over 54 times a 6x plus 1 to the 1/2 power. I would then be left with 6x plus 1, and then that's minus 3. Well, 6x plus 1 minus 3 becomes a 6x minus 2. Well, I can factor out a 2 from these two, and that is 2 over 54 times 6x plus 1 to the 1/2, and then that's 3x minus 1. Well, 2 over 54 reduces to 1 over 27, so in the end we end up with 1 over 27 times 6x plus 1 to the 1/2 times 3x minus 1 plus c, and this guy is the exact same thing we got when we used integration by parts. Now, when you're on an exam or in a homework problem and you're doing a problem like this, please don't do it with both methods. Choose your favorite method and do it that way. The only time you have to do it a certain way is if the instructions are asking you to use integration by parts or to use a change of variable. So if you have to use integration by parts, you have to do it this way. If you have to use change of variable, you have to do it that way. And that would be the homework that might ask it that way. On an exam, you would never get it that way. You would choose your favorite method to find the indefinite integral. Let's keep going. Number 6. The cubed root of x times the natural log of x dx. Well, radicals in calculus still don't get along, even with integration by parts, so we're going to write this as x to the 1/3 times the natural log of x dx. This is not basic form, it's not a u-sub, so we know it's integration by parts, and we use Lie8. Well, Lie8 says if you have a log, which we do, that's your u. So if u is equal to the natural log of x, I'm going to go ahead and already find the derivative. The derivative du would be 1 over x dx. Everything else in the integrand is my dv, so I have dv is equal to x to the 1/3 dx. Integrating that, I would end up with x, raise it to 1 more, to the 4/3 times the reciprocal of 4/3, which is 3/4. Now, this becomes u times v, ln of x, times 3 over 4 x to the 4/3, minus the integral of v du, 3/4 x to the 4/3, times, say, 1 over x dx. Clean this up before we integrate again. So we're going to write 3 over 4 x to the 4/3 times the natural log of x. I can factor out that 3 over 4. And then x to the 4/3 times 1 over x, well, I can reduce that, and that just becomes x to the positive 1/3 dx. Integrating this again, and that's just basic form. We'd have, this is x to the 4/3 times the reciprocal, 3/4 plus c. In the end, we're looking at 3/4 x to the 4/3 times the natural log of x minus 9 over 16 x to the 4/3 plus c.